Alright, so in this video, we're gonna start off with our first topic in electrochemistry. In Chemistry 0620, Cambridge IGCSE, this is a topic or chapter 10 in the book named Redox Reactions. So this is gonna be a series of approximately 3 to 4 videos. Alright, this is the first video of electrochemistry. So we're gonna start off by defining what is a redox reaction, okay? A redox or redox reaction is a chemical reaction that shows both oxidation and reduction at the same time. So it is a chemical reaction that has both oxidation and reduction at the same time. But of course, we don't know what is oxidation and reduction, right? Let's have a look. Oxidation and reduction. Oxidation is loss or donation of electrons in a chemical reaction. Okay, signs of oxidation include the number of oxygen atoms increases, the number of hydrogen atoms decreases, and the charge or oxidation number increases. So oxidation is loss of electrons in a chemical reaction. Electrons are lost from the chemical reaction in the product side. The signs of oxidation: oxygen increases, hydrogen decreases, charge or oxidation number increases. Reduction. Reduction is the opposite of oxidation. In reduction, electrons are gained in the chemical reaction on the reactant side, on the left side of the chemical reaction where the reactant is. Electrons are gained. It is the exact opposite of oxidation. So number of oxygen atoms will increase in oxidation, number of oxygen atoms will decrease in reduction. Number of hydrogen will decrease in oxidation, number of hydrogen atoms will increase in reduction. The charge increases in oxidation, so the charge will decrease in reduction. If you cannot memorize both, just memorize one and you will automatically know the definition and the signs of the other. Just remember, one is the opposite of the other. So if you're not able to remember both, just remember oxidation and remember that reduction is the opposite. Or remember reduction and remember that oxidation is the opposite. Alright? How can we determine the changes? So let's have a few simple examples here. C3H6O is converted into C3H6O2. So oxygen has increased. And what is this? Oxidation or reduction? It is oxidation because oxidation is number of oxygen atoms increases. C5H8. Over here also hydrogen increased. So what is this? Reduction. In reduction, hydrogen increases. H2O, H2O2, what increased? Oxygen. Oxygen increases equal to? Yes, oxidation. Okay, so this is a memory aid to help you remember oxidation and reduction. Oil rig. Oxidation is loss of electrons, giving out donation of electrons in the product side. Reduction is gain of electrons, where in the reactant side. Alright, moving on. Two common examples of oxidation is corrosion and rancid. Corrosion is when metals and alloys are chemically attracted by oxygen and hydrogen oxide and other compounds to form rust. Rust is a brown flasky form of iron oxide that weakens structures. So basically, corrosion is just when metals or alloys react with oxygen in the air and water, or like water vapor in the air, and they form compound rust. Okay, basically the metal chemically reacts with the oxygen and hydrogen and forms a weak unreactive layer on the top of the metal, which can easily be replaced, forming in rust. The next example is rancid. Rancid is oxidized organic materials or foods with a bad smell, usually due to poor food keeping or protection. Now coming to the important part, agents of redox reactions. So we have two agents in redox reactions, actually two main agents, and then we have a side one here. The reducing agent and the oxidizing agent. It's a bit confusing, but you'll get used to it. Reducing agent is the reactant. Remember, agents of redox reactions are always reactants. It is a reactant which is oxidized, donates electrons during the reaction. Oxidizing agent is the reactant which is reduced, gains electrons during the reaction. So basically the reducing agent is the one that is oxidized, the reactant that is oxidized. Oxidation is loss of electrons. So you can remember it as the reducing agent is the reactant that loses electrons, which is oxidation, An oxidizing agent is a reactant which is reduced or gains electron, okay, again during the reaction. So as the reducing agent reduces another substance, it becomes oxidized in the process, okay? So while the one reactant in the chemical reaction is oxidizing itself, okay, is donating electrons, it is reducing another substance. So basically, for example, a reactant is losing electrons, okay? It is being oxidized. Where are these electrons going? To another substance, correct? So that substance is being reduced, it gains electron. So the one that gave the electron is a reducing agent. It's reduced another substance by becoming oxidized in the process, okay? Oxidizing agent does the opposite. The reactant to which is reduced, it gains electrons, okay? It oxidizes another substance, meaning it gains electrons from another substance. It takes electrons from another substance, so that substance is losing electrons and becoming oxidized, okay? Some examples of common reducing agents include carbon and hydrogen. Examples of common oxidizing agents include fluorine, chlorine, and hydrogen peroxide. Spectator ion. Spectator ion is basically like the neutral guy here, okay? It's like the ion or compound in a redox reaction. It does not change at all, okay? It is not oxidized, it is not reduced. It remains the same throughout the whole reaction, in the reactant side and in the product side. The spectator ion is the one that remains the same. Okay, so the last part here is identifying charges, okay, a shorthand rule. So basically, any element that you see in a chemical reaction is not bonded. A singular element has zero charge, okay? Any element that is bonded in a compound or molecule has a charge, okay? And so basically here are the common charges of some bonded elements in compounds, and the same ones over here are non-bonded. So any non-bonded element, take any element that is singular, not bonded, it has a zero charge. Because again, the atoms are actually neutral unless they go through a process of bonding in which they will share or lose gain electrons. Otherwise, atoms are neutral, okay, and the positive protons and negative electrons are equivalent. So the charge of bonded elements in compounds, basically elements that are bonded in compounds and molecules, have specific charges, okay? Positive 1 is for lithium, sodium, potassium, hydrogen. Positive 2 is for beryllium, magnesium, calcium, barium. Positive 3 is for boron, aluminium. Negative 1 is the halogens, fluorine, chlorine, bromine, iodine, group 7. Negative 2 is oxygen, sulfur. Negative 3, nitrogen, and phosphorus. It's optional to remember these, but I would really recommend you to remember these as it's going to help you in calculating the redox reactions. Okay, so now we're gonna go through a list of redox reactions, and we're going to be identifying the redox reactions, the reducing agents, oxidizing agents, what's oxidized, what's reduced, and etc. Okay, so basically practice questions. I'll be solving 5 questions here, and for the last one, I will give you time to solve it. So, nitrogen plus chlorine gives you sodium. Sorry, my bad. This is supposed to be Na. Yes. Sodium plus chlorine gives you sodium chloride. Okay. Now I want you to look here. Sodium, what happened? Sodium is not bonded, meaning the charge is 0. Chlorine is not bonded, the charge is 0. Okay. When they become bonded, the charge of sodium increases. So this is oxidation, increase in charge. The charge of chlorine is -1 when it's bonded. So 0 to -1, charge decreases. It is reduced. So sodium is oxidized because the charge is increased. Chlorine is reduced because the charge is decreased. This means sodium is the reducing agent. It oxidizes... it is oxidized and reduces chlorine. Chlorine is the oxidizing agent. It is reduced oxidizing sodium. Another example, magnesium plus sulfur gives you magnesium. Okay. So magnesium is unbonded, sulfur is unbonded, 0 charge. Magnesium bonded, if you refer back to the shorthand rule, bonded magnesium has a charge of +2 and bonded sulfur has a charge of -2. So sorry, the camera is a bit, let me just fix the camera again. Yep. So magnesium is +2, so sulfur is -2. Charge of magnesium is increased, magnesium is oxidized. Charge of sulfur is decreased, sulfur is reduced. Another example, calcium plus magnesium sulfate gives calcium sulfate plus magnesium. Here, what is not bonded? Calcium. Charge is 0. Now in the product, calcium is bonded, charge is increased to +2. What is bonded? Magnesium and sulfate. Magnesium +2, sulfate -2. Magnesium is unbonded in the product side, magnesium charge is 0. Charge of magnesium is reduced, so magnesium is reduced. Now, let's look at the spectator ion. What has no change? Sulfate in both reactant and product side did not change. The charge remains the same. So sulfate is a spectator ion. There's no change in its charge. While magnesium reduced its charge, so it's decreased. Calcium increased in charge, it's oxidized. Question 4. Chlorine plus potassium iodide gives potassium chloride plus iodine. So what is not bonded? Chlorine. So charge is 0. In the product, is chlorine bonded? Yes. What is the charge of chlorine when it's bonded? -1. So what happens to its charge? It's reduced. So what is chlorine? It's reduced. What about the rest? Okay, so yeah, potassium and iodine. Are they bonded? Yes. Charge of potassium when it's bonded? +1. In the product, +1, spectator ion. Charge of iodine, -1. Charge of iodine in the product, 0. What happened? Charge increased. So, what is iodine? Oxidized. This is a bit confusing because you should be careful when you are dealing with negative and positive numbers. Many a time you're going to see -1 to 0, the charge is increased, so be careful about that. For the last question, the answer is there, so I'm just going to give you some time to solve the question, okay, just as it is. Write it on a paper, write the question down on a paper, and just take your time to solve this question, okay? After you've done this, I'm gonna end the video here, and we're gonna continue with the next part of this same sheet in the next video.